Alright, for 17 we've got some free body diagrams to draw. I'm going to go through these relatively quickly. So when an object lies motionless, we've got a normal force, and we've got a weight force, and these balance. Now here's the interesting part. For part B, it turns out it's exactly the same free body diagram. There's no friction, so there's no forward force needed to keep it moving. So yes, at some point in its past there was an unbalanced force that started it. But then if we're on a frictionless surface, once that force stops acting, the object no longer accelerates and it continues moving in a straight line at a steady speed. Now, the object here slows due to kinetic friction. So we're going to have the same free body diagram with a little modification. We're going to have a friction force opposing its motion. What we're basically saying is the object moves to the right, and so friction opposes the intended direction of motion and goes to the left. Now here, we're going to have a tension force, and we're going to have the weight. Notice I called it weight. Force of gravity and weight are identical. Now here, the object is pulled upward at a constant speed. It's interesting. I'm a little annoyed at this because if I had been drawing this, I would have made this thing a little ft here to remind you that it's tension, and then that means the force up would be a tension and the force down would be a tension, as would be gravity or weight as well. Sorry, so it's ft and fg, so it's actually identical to the answer for D. Now here, a force is pulled by the object is pulled by a force parallel to the surface. It turns out there's a couple possibilities. So some people had Fg and Fn, which is this part every free body diagram here should have. And you should also have an F drawn here. A lot of students wanted this to be the applied force, so they'll put a little A there. Now, I'm going to draw a dotted line for friction just to indicate it's not required for a correct answer. So I'll say not required in this case. Okay. Next, when we're free falling with no air resistance, we only have Fg acting. And lastly, when we're falling at terminal velocity, the forces are balanced since we're moving at constant velocity. And that means we have a drag force going up, and we have the gravity force, or the weight, acting down. They balance so that the object goes at a constant velocity. So those are the free body diagrams for number 17.